right, 1.5, here we go. Zeros of a polynomial. Robbie's going to read. Given.
Given a polynomial function p of x, if p of a equals 0, then a is a 0 of root of p of x.
Or a root. All right, what is a 0 or a root synonymous with? A lot of the times we'll call it a what? An x-intercept. It's going to basically be an x-intercept. And what I'm doing is I'm setting my function equal to 0. I'm setting my y equal to 0 because the x-axis is also known as y equals 0. Okay, it's the same kind of line. All right, keep going.
If a is a real number, then if x equals a is a 0 of p, then x minus a is a linear factor of p.
All right, perfect. All right, and so this is just the linear factorization form, and then this is our 0 form. All right, pick a reader.
Lucas.
All right. Repeated zeros, multiplicity. If the linear factor x minus a is repeated n times, the corresponding 0 of the polynomial has a multiplicity n.
Good.
Typically, we know that the graph of a polynomial passes
through
the zeros on the graph. However, when a 0 has a multiplicity greater than 1, the graph will behave differently near the 0. The function y equals negative 0.01 parentheses x plus 4 parentheses x plus 1 to the power of 3 parentheses x minus 3 squared is graphed to the right. Notice the behavior around the zeros of the function.
All right, let's talk about it. So if we have this function, if I have the factorization of x plus 4, where is my 0 at? Where's my 0 located? Negative 4. And so that's why it crosses at negative 4. Now, what did it do at negative 4? It went what? Okay, it went up at negative 4, but it went through negative 4. Okay? And then at x plus 1 cubed, where is it going to cross at? At negative 1. All right? And so that's what this is basically doing. And so it crosses at negative 1, right? And so how about x minus 3? Where's it going to cross? At positive 3. But did it go through 3? It did not. What did it do? It touched it. I call it a bounce. Does anybody know why it bounced? All right, let's keep moving then. We'll figure it out. All right, so the next box, Lucas, pick a reader.
Josh.
Right below
The multiplicity.
The multiplicity of a 0 is the
degree of its factor. It's the degree of its factor. So, for instance, at negative 4, I have a multiplicity of 1. At negative 1, I have a multiplicity of 3. And at 3, I have a multiplicity of 2. And so, when I have a degree that's even, if I have a degree that's even, a multiplicity that's even, it bounces. All right? And it's said that the graph will always be tangent to the line or to the y-axis at that 0. But it bounces. If it's odd, guess what it does? It goes through. And if it's even, it bounces. All right, let's keep going on our example 1. All right, so for this example, we're going to determine the degree of the polynomial. We're going to find the zeros and the multiplicity, and I'm going to kind of talk about what it would actually do. All right, so let's look at part A. What's the degree?
3.
This is not a degree of 3. It's a degree of 6. All right, and so let's talk about why it's a degree of 6. So this is a cube, right? What's the power here? 1. What's the power here? 2. So what do you do with all of them? You add them up. All right, you kind of like distribute almost. And so you add them up. So now we have a degree of 6. So now when we're trying to find our zeros, we're going to set each linear factorization equal to 0. So I'm setting negative 2x cubed equal to 0. And so what am I going to get there? What's my 0? When I set 2x cubed equal, or negative 2x cubed equal to 0, what's my 0? 0. So I have a 0, 0. And what's the multiplicity of it? What's the degree of that 0? It's 3. All right, do you see the cube? All right, let's try the next part then. And so now I'm going to set this x plus 1 equal to 0. And so what's my 0 on this one? Negative 1, comma 0. Because it's an ordered pair where it crosses the x-axis. And so then what's its multiplicity? 1. All right, it has a degree of 1. It's just not explicitly shown. And then what's my other 0? 4, comma 0. And what's its multiplicity? 2. Now, what's it doing at 0? Is it going through or is it bouncing? At 0. What's it doing at 0? It's going through. Why is it going through? Because it's odd. How about negative 1? What's it doing? It's going through. How about at 4? What's it doing? It's bouncing because now we're even. Make sense? All right, we're going to do it again. So let's look at part B now. And so whenever I have something that's not completely factored, I'm going to factor it. All right, so I have x squared minus 4. Is that a completely factored term? No, let's F it up. All right, and so what does that factor to?
X plus 4, x minus 4.
Let's try it again. X what? X plus 2, x minus 2. All right, it's a difference of squares. All right, so now that I have those factored, what should I do with this x minus 2 and this x minus 2 to the 4th thing? What should I do with those two things? I should combine them. All right, I should combine those things. So now I end up having g of x is equal to 3 times x plus 2 times x minus 2 to the power of what? 5. I add the powers. All right, so I have 1 plus 4, so now I have 5 of them. All right, and so what's my degree of this function now? All right, so do I have any variables here? No, so I don't need to worry about that one. Do I have any powers here? Yes, what is this? 1, and then I have 5, so what's my degree of this whole thing? 6. And so now let's find our zeros. And so to find our zeros, can I set 3 equal to 0? No, it doesn't have a variable, so I don't have anything there. Can I set x plus 2 equal to 0? Yes, what am I going to get? Negative 2, comma 0. So what's that one's multiplicity? 1. So what's it going to do at negative 2? It's going to cut through. It's odd. All right, and then when I set x minus 2 to the 5th equal to 0, so what do I get there? 2, comma 0. And so what's that's multiplicity? It's 5. All right, what's it going to do at 2? It's going to cut through. All right, so let's do it again. So now we have y equals that function. And again, on these functions, what should we try to do first? Factor them. Let's F them up. So what can we factor on that trinomial? We're going to factor out an x. And so now I'm left with x squared minus x minus 6. And then I still have x squared minus 7x plus 12. Now, I know some of you factor a quadratic trinomial with like the AC method thing, and some people do guess and check. I'm always going to do guess and check in my head. All right, so if you do the AC method, you do you. However, I'm personally not. All right, so I'd like you to factor these. So the first quadratic trinomial, what does it factor to? X minus 3 and x plus 2. Love it. And then what's my second quadratic trinomial factor to? X what? X minus 4, x minus 3. Beautiful. All right. And so what should we do with our like factors? We should combine them. And so now we end up having y is equal to x times x minus 3 what? Squared. And then I have x plus 2 and then x minus 4. So what's my degree on this one? What's my degree on this whole thing? So this is 1, this is 2 more, this is 1, this is 1, right? And so how much are all of them? 5. All right. You could also think about the first thing that we dealt with. If I multiply an x cubed with an x squared, what do we get? A degree of 5. And that's going to be my highest degree that I'm going to get. And so we have a degree of 5. Now, let's find our zeros. So when I set x equal to 0, what do I get? I get 0, 0. All right. And so what's its multiplicity, though? 1. What's it going to do at 0? It's going to cut through. And then how about x minus 3 equal to 0? So what's that 0? 3, 0. And what's that multiplicity? 2. What's that going to do graphically? It's going to bounce. All right. And then x plus 2. So now I have what? Negative 2 comma 0. And so what's that multiplicity? 1. So what does that mean graphically? It cuts through. And then x minus 4. What's that 0? 4 comma 0. And so what's that multiplicity? That is also 1. All right. Pretty good? All right, we're moving. So now let's talk about complex roots. Who is the last reader?
Complex roots. Some polynomials have roots that contain an imaginary number. This means you will
Not see them.
on the graph. The graph of f of x equals x squared plus 2 is shown to the right. To find the zeros of f of x, we set x squared plus 1 equals 0.
All right, beautiful. So I have this basic quadratic function shifted up 1. All right, that's what the plus 1 did. All right, it just shifts up 1. Now, if I set this equal to 0, does it cross the x-axis? Because really when we're setting it equals 0, we're finding zeros, right? 0 is also synonymous with what? Say an x-intercept. It's an x-intercept, all right? So does it cross the x-axis? No, but you'll see on the next page when we talk about fundamental theorem of algebra, it should cross twice. However, let's see what happens. So when I set x squared plus 1 equal to 0, and now if I shift over 1, if I subtract 1 from both sides, I now have x squared minus x squared is equal to negative 1. And so then when I square root it, I end up getting a plus or minus square root negative 1. Well, what is that square root negative 1 thing? That's I. All right, and so that deals with an imaginary number. And so how many imaginary numbers did I actually have here? I have 2, because I have a positive imaginary and a negative imaginary. All right, and so that leads us into these things right here. Asher, keep reading. You're doing great.
All imaginary roots come in
Pairs. They come in pairs.
if a plus bi is a root of f of x, and so is
They come in pairs. You also have a minus bi. And these are called conjugate pairs. All right? Example. So we need to determine the conjugate of these complex numbers. So if I have 4i, what is its buddy? Who's its pair? Negative 4i. And if I have negative I, who's its pair? I, because they travel in groups. And so then if I have 2 minus 3i, who's its buddy? 2 plus 3i. And then if you have negative 4 plus 2i, who else comes with them? Negative 4 minus 2i. All right? You will always have conjugate pairs with complex numbers. All right? Complex roots. All right? And so let's talk about the fundamental theorem of your entire last course. All right? I need a good reader. Thank you so much, Robert, for volunteering. Go for it.
A polynomial of degree n has exactly n complex zeros with counting multiplicities.
Beautiful. All right? That's what you learned the entire last year. All right? And so if you have a degree of 7 for your polynomial, how many zeros do you have? 7. Now, are all of them real? No, that does not mean your function is going to cross the x-axis 7 times. Okay? Some of them are what? Imaginary. They are complex. And so if you have a complex, guess how many complexes you really have? 2 or 4 or 6, because they always travel in what? Pairs. Okay? All right, so let's look at this example. So this example is a polynomial, and it's known that x is equal to x equals I square root 3 is a root or a 0 of f. So if I square root 3 is a root or a 0 of f, what else do you know? negative I square root 3 is also a 0 or a root. All right? Because they, negative, thank you. All right? Because they travel in what? Pairs. All right? And so if f has degree n, what is the least possible value of n? So we need to figure out what the least power can possibly be on this function. So how many powers do I have right now? If I have I square root 3 and negative I square root 3, what am I up to right now? I'm up to 2. All right? And so now I got to kind of look at my real zeros going on. Do you see how like this is actually touching at 0 and this is touching right here? All right? And so now, what's this 0 there? Negative 1. So what do you know about x equals negative 1? It's an even multiplicity. How did we know? So this multiplicity has to be at least what? 2. At the very least, it's 2. It could be 4, it could be 6, it could be whatever. But its multiplicity is at least 2. How did we know that, Campbell?
I couldn't tell you.
Let's look at our graph. How do we know it's a multiplicity that's an even? Because it bounces. So the least it could be is 2. I don't know. It could be 4, it could be 6, it could be 18. However, I know the least it can be is what? 2. Because it does what? Because it bounces. All right? So where else do I have a 0? I also have a 0 at 3. Now, what is the least multiplicity that could have? 1. Because why? Because it cuts through. And so what is the least degree of this polynomial? This is at least a degree of what? 5. Why is it at least 5? Because what are my imaginaries? That's at least how many? 2. And then this bounce has to have at least how many more? 2. And then this multiplicity of 1 has to have at least how many more? 1. So we're up to how much? 5. Now, could it be a 7? Sure. Could it be a 9? Yes. Could it be a 6? No, it cannot be a 6. All right? Because of my end behavior, for this lesson, I am going to finish up this lesson on Monday on 1.5. However, I want you to go to worksheet A. I want you to go to worksheet A. Beautiful. All right, so Kefa, what's the degree of this polynomial? 3. All right, yes, no, number 6, it is 3. All right, so now how do we find the zeros? I'm going to eventually set this equal to 0, right? But what should I do with this one first? I should factor it, all right? And so what does this factor to? What can I bring out first? An x. And so then I'm left with what? X squared plus 10x plus 25. And now I'm going to factor that one. And so now that would factor to what? X times x plus 5 and x plus 5. Okay, and then what did we do with that part? I think Campbell already did it. What did we do with that part? X times what? X plus 5 squared. Exactly. All right. And so what's one of my zeros? What's this 0? 0. So now I have 0, 0. And what's that multiplicity? 1. What did that do graphically? Cuts through. All right. And so then if I set x plus 5 equal to 0, I end up with what? Negative 5 comma 0. And what was that multiplicity? 2. What would that do graphically? Bounce. All right, beautiful. All right, let's move to 19. I think on 19 it just says factor it if you can, basically. All right, and so we're going to just practice our factoring here. I'm going to kind of talk about it further, but we're just going to practice our factoring. So what does x squared minus 49 factor to? X what? Plus 7 and minus 7. And then what does that quadratic trinomial factor to? X plus 7 and then x minus 2. And so what should we do with these terms now? We can't cross them out. It's not dividing. All right. And so now our x plus 7s, what should we do with those? We combine them. And so now we have x plus 7 quantity squared. And then I have x minus 7, and then I'd also have x minus 2. I know this isn't asking for it, but I want to keep going with it. What is my 0 of this first term? Negative 7. What's it going to do at negative 7? It's going to bounce. What's it going to do here? What's that 0? 7. It's going to cut through. What's it going to do here? It's going to cut through at what? 2. All right. And so I want you to finish up worksheet A.